Hello everyone, welcome to today's YouTube video on how to calculate pi using equation of a circle, binomial theorem and integration. So we're going to use these three things to do this. So we know that the equation of a circle is given by a squared plus y squared is equal to r squared. So if the circle is a unit circle, that is if it has a radius 1, so we have that x squared plus y squared is equal to 1, and we can make a subject formula. You know that this is the x-axis and this is the y-axis. We can make subject formula to have that y is equal to 1 minus x squared 1 minus a squared all square root. So that is the equation, the function y. For every x you get the value of y, for every x you get the value of y, so that's what you get. Okay, let's also consider what we have done in binomial theorem. You can see our videos on binomial theorem. You find that if we have 1 plus n, 1 plus x raised to power n, that we are going to have something like this. 1 plus nx plus 1 over 2 factorial n into n minus 1 x squared plus 1 over 3 factorial into n minus 1 n minus 2 x raised to power 3 plus 1 over if you like 4 factorial n into n minus 1 n minus 2 n minus 3 x raised to power 4 plus and so forth and so on. That's what you have when you open it binomially. So that from here you see that we can easily substitute x for x squared and n for half. If we do that, our equation will now look like therefore 1 minus x squared all raised to power half. If we open it up, we'll have 1 for this one plus n is half and x is minus x squared. That's what we have, plus 1 over 2 factorial is 1 over 2 times 1, that's 1 over 2 for this one is 1 over 2, this one is minus 1 over 2, good, x is minus x squared, then raised to power 2 plus this one is 1 over 3 times 2 times 1, 6, this one is half, this one is minus half, this one is minus 3 over 2, that's 3 over 2, then x is minus x squared all raised to power 3. All raised to power 3. So we can do it for the next one, which is 4 times 3 times 2 times 1. 4 times 3, 12 times 2, 24. So we have 1 over 24 into half minus half for this one, minus 3 over 2 for this one, minus 5 over 2 for this one. Then x is minus x squared. We are replacing x in that binomial formula. So, and so forth and so on. So we have how many terms now? 1, 2, 3, 4, 5 terms. So that if we now open the whole stuff up, we have that it is equal to 1. This one is minus x squared over 2. Let me use another color. X squared over 2. 1 minus x squared over 2. This one is plus. Minus minus plus, so it will give us plus. The one will give us minus x raised to power 4 over 8 for this one. This one will give us 3 over 8 times this 48. 48, 3 over 48, that's 1 over 16. 1 over 16, that is minus x raised to power 6 over 16, minus this one will give us 5 on top over this times this times this times this is 16. 16 times 24 is around 128. 128 times x raised to power 8. 2 times 4 is 8, plus and so forth and so on. But it's going to be minus, but let's just say plus and so forth and so on. So we find that our y, which is equal to 1 minus x squared all square root, if we open it up binomially, we'll have this. So what this thing now means is that for instance, if we have a circle, a semicircle, of course it's a semicircle from 0 to 1, and we want to calculate the area now under this curve, the area under this curve. So it means that if we integrate between 0 and 1 for y, that's the x. So what we have is actually 0 to 1 of 1 minus x squared half dx, which is all these things that we have here, which is equal to square root of 0 to 1 of 1 minus x squared over 2 minus x4 over 8 minus x raised to power 6 over 16 minus 5x raised to power 8 over 128 plus then dx. So if we do it between 0 and 1, it means that what we are looking for is this area, and this area is just 1/4 of the area of a circle is pi r squared. So if it has radius 1, it means that the area of a unit circle is pi. Area of a unit circle is pi. So let me write it. Area of unit circle is equal to pi, because r is 1, r squared is 1. So that area of this quadrant will now be pi over 4. So what we are going to get will give us equal to pi over 4. So if we're able to get this and we'll cross multiply with this, we'll get the value of pi which we are looking for. So that if we integrate this, of course, we'll have is equal to x minus x3 over x3 over, remember this one will be x2 plus 1 over 3 plus 1, so it will be x3 over 6 minus this one will be x raised to power 4 over 5 times this, so it will be x5 over 40 minus this one will be integration of x raised to power 6 is x raised to power 7 over 7, so 8 raised to power 7 over 7 times 16 will give us x raised to power 7 over 112, because 16 times 7 is 112. This one will be 128 times 9, because this one, if we integrate this, we'll have 5x raised to power 9 over 128 times 9. So we'll have minus 5x raised to power 9 over 128 times 9 is 1152 plus so the boundary is between 0 and 1 is equal to, so if we can say times 4 here is equal to pi, times 4 is equal to pi. So we can do that, so that of course if we plug in 0 in all these things, we'll get 0. If we plug in 1, we'll have is equal to 4 into 1 minus 1 over 6 minus 1 over 40 minus 1 over 112 minus 5 over 1152 plus and so forth and so on. But let's stop at the 5th term. If we stop at the 5th term, that's what we have is equal to pi. So that if we evaluate this thing in this square bracket and multiply by 4, we get approximately 3.1802. So this is what Newton did in order to calculate pi and to save us from the rigor of using hexagons to find it, polygons if you like, because people were using, for instance, hexagon inscribed in a circle of sides 1, 1, 1, 1, 1, 1. So that from here to here is 2. So they were using this thing and doing all sorts of geometric calculations. For this one, you find out that pi will be less than 3. Pi will be more than 3 and less than 4. So, but some people did it up to 2 quintillions in order to get the accurate value of pi. But Newton was able to do this using this method. So let us see what will happen if we integrate between 0 and half. 0 and half. Remember, this is 1. So here is half and here is half. If we integrate between 0 and half, that means that we are looking at area here. We are looking at area, this shaded place. That's what we are looking for. And it means that if we take this angle to be 30 degrees, if we take this angle to be 30 degrees, and that means that here is going to be 1. If that means here is 60 degrees. Of course, you know trigonometrical ratios. So you are going to have something like this. Here will also be 60. so that this place will give you root 3 over 2, and here is 1 over 2. This place will give you root 3 over 2. So, but if we divide a circle, if we divide the unit circle into using 30 degrees, remember the angle in a circle is equal to 360 degrees. So if we divide it by 30 degrees, so we'll have 12. So it means that this area here, this area that I'm marking with blue now, this area is equal to pi over 12. So that area is equal to pi over 12. This area, since we have found this area is equal to half base times height. Half base times height. And half base times height is half times half times root 3 over 2. So that's root 3 over 8. So it means that the area of this whole thing, the shaded portion, the area of this shaded portion, blue and red, is equal to total area. Total area there is equal to pi over 12 plus root 3 over 8 plus root 3 over 8. So if we use it now, we can easily get what we are doing, and what we are doing is this: to plug in y, the x between 0 and half. If we do that now, what we get is simply coming here and substituting with substituting half inside there. If we substitute half inside there, we'll have let me write that this thing, for instance, is half 0, 1 minus x squared raised to power half, and it's equal to pi over 12 plus root 3 over 8 is equal to. So let us now plug in halves in this equation, that we have obtained, this equation, but equating it now to this, because it's no longer a semicircle. It's no longer a semicircle. A quadrant is just at the 0.5 mark along the x-axis. So if we do that, what we will now have is, if we put half in this equation, that we have integrated before, this thing in this bracket is what we have integrated to obtain this very formula. So if we put half there, we'll have half minus, this is 1 over 6 times 1 over 2 raised to power 3 minus, let me use another bar, minus, this one will give us 1 over 40 times 1 over 2 raised to power 5. This one will, let me start, sorry. So what we have just done is to plug in the halves. Plug in the halves into this halves into these places, into these coefficients, into these variables that we have obtained from our integration. So if we put half here, we get this. If we put half here, we get this. If we put half here, we get this. If we put half here now, we'll get, let me start here, minus 1 over 112 half raised to power 7 minus 5, and this one 5 over 1152 half raised to power 9. So let's stop at the fifth term, 1 2 3 4 5. If we stop there, we will have this, so that we will now have that So what we want to solve is this whole thing. That's what we want to solve, this whole thing. So we will now have that pi over 12 is equal to, if we evaluate all this thing in bracket, we will have 0.4783071 minus root 3 over 8 is 0.2165063,509. So that pi will be equal to 12 times, so if you subtract this, you have 0.261800834, and that's approximately 3.14161000098. So that is the value of pi from equation of cycle, binomial theorem, and integration. Thanks. Let's stop here. Thanks. And please subscribe. Bye.